Hello, let's start the summation. Summation q belongs to n naught, which is natural numbers including 0, which is whole numbers of cos of q pi by 2 by q plus 1 into q plus 2 into q plus 3. So let's start. Consider, as you know, um, let's start summation n belongs to n to infinity y power n, right? Consider this case. This can be written as, if you expand this, here this will be, here it's natural numbers not including 0. Our case is including 0. So here it will be y plus y square plus y cube plus and so on. If you take y as common here, it will be 1 plus y plus y square plus and so on, which can be written as y into 1 minus 5 whole power minus 1, right? Which is summation n belongs to n to infinity y power n can be written as y by 1 minus 5, right? Now similarly, let's consider y equal to x into e power I theta. Fine. Then summation n belongs to n to infinity y is x into e power I theta whole power n. Then this will be x power n e power I n theta, which can be written as y by 1 minus 5, which is x into e power I theta by 1 minus x into e power I theta. Fine. So let's try to rationalize the denominator. So we can multiply and divide with 1 minus x into e power minus I theta by 1 minus x into e power minus I theta, which is x into e power I theta minus this is x square, then e power 0 will be 1 by this is 1 into 1 1 minus x into e power minus I theta minus x into e power I theta, then this will be minus into minus plus x square, e power 0 is 1, that is x into e power I theta minus x square by 1 minus, as you can see, e power minus I theta plus e power I theta, right? If you take minus x as common, this will be, you will get only the cos term. As you know, e power I theta is cos theta plus I sin theta. It will get sin theta will get cancelled and it will get cos term. So this will be 2x cos theta plus x square, right? This is summation n belongs to n to infinity x power n into e power I n theta case. Now here we are going to consider taking the real part, right? If you consider the real part in equation 1, here the real part is e power I n theta, real part is cos n theta, right? That is what we needed it here in the numerator, cos q pi by 2. Fine. Taking the real part, it will be summation n belongs to n to infinity x power n into cos n theta, right? This will be, if you take in the e power I theta, real part is cos theta minus x square by 1 minus 2x cos theta plus x square. So our case is n naught. I mean, we need to include even 0, right? If n equal to 0, x power n into cos n theta will become 1. So if you include even the 0 case, n naught to infinity, x power n cos of n theta will be, it will be 1 plus x cos theta minus x square by 1 minus 2x cos theta plus x square. Now if you simplify this will be 1 minus 2x cos theta plus x cos theta will be minus x cos theta plus x square minus x square will get cancelled, then the denominator will be as it is. Right, now in our case, as you can see here, there is, in the numerator we have cos q pi by 2, which is, I mean, cos n pi by 2. So our theta value is n pi by 2. So let's do it. Summation n belongs to n naught to infinity x power n cos of n pi by 2, which is 1 minus cos 90 is 0, then this will be 0 by 1 plus x square. Even the second case, 2x cos theta will get 0 cos 90, right? And this will be 1 by 1 plus x square. So let's make this statement here. Function n belongs to n naught to infinity x power n cos of n pi by 2 is 1 by 1 plus x square. So our case is, let this is equation 2, right? Our case is summation q belongs to n naught cos of q pi by 2 by q plus 1 into q plus 2 into q plus 3. So first what we need to do is, as you can see in the denominator, it is 1 by q plus 1 into q plus 2 into q plus 3. Using partial fractions, you can do a by q plus 1 plus b by q plus 2 plus c by q plus 3. So this will be 1 by q plus 1 into q plus 2 into q plus 3. Then this will be a into q plus 2 into q plus 3 plus b into q plus 1 into q plus 3 plus c into q plus 1 into q plus 2 by q plus 1 into q plus 2 into q plus 3. So the numerators must equal in this case, right? As you can see, when, let's consider, if q equal to minus 1, that implies q equal to minus 1, this term will go, this term will go, right? The remaining term will be a into minus 1 plus 2, 1, minus 1 plus 3, 2, equal to 1, which is on the left hand side. That is a equal to half. Then if q equal to, for b case, let q equal to minus 2, so that, I mean, you will go, if q equal to minus 2, c will get 0, a will get 0, then b into minus 2 plus 1 minus 1 minus 2 plus 3 1 is equal to 1. That implies b equal to minus 1. If q equal to minus 3, as you can see, if q equal to minus 3, a and b will get 0. The quotients of a and b will get 0. Then this will be c into minus 3 plus 1 minus 2 minus 3 plus 2 minus 3 plus 2 minus 1 equal to 1. That implies c equal to minus 2 into minus 1 plus 2, right? This will be c equal to half. That is, this case it can be written as, write it down, summation q belongs to n naught to infinity this can be written as cos q pi by 2 into a value is 1 by 2, right? This is 1 by 2 into 1 by you can write it as n plus 1 or q plus 1 or whatever you feel like. Similarly, in the b case, it will be b equal to minus, right? Minus 1 by n plus 2 plus c is 1 by 2 1 by 2 into 1 by n plus 3. That is, as you can see, we have faced these denominators 1 by n plus 1, 1 by n plus 2, 1 by n plus 3. Similarly, as you can see, this, if you integrate x power n, this will be x power n plus 1 by n plus 1. So to get the numerator part as 1, you can just substitute the limits 0 to 1. Then this will be 1 power n plus 1 by 1 power n plus 1 by n plus 1, which is 1 by n plus 1, minus 0 by n plus 1 is 0. So let's try to substitute these things in here. Summation, that is, let's write it down here more clearly. Summation q belongs to n naught cos of q pi by 2 by q plus 1 into q plus 2 into q plus 3 is, you can write this as integral 0 to 1 summation q belongs to n naught cos of q pi by 2 into one by 2 into, as the first case is 1 by n plus 1, right? Then it can be written as x power n, minus the second case is n plus 2, then this can be written as x power n plus 1. The third part is half into n plus 3, then this will be plus half into x power n plus 2 dx. Fine. Then let's do one thing. Let's bring the half factor common. Then this will be integral 0 to 1 summation q belongs to n naught cos of q pi by 2, and this will be x power n. This will be minus 2 into x power n plus 1. As you can see, there is no 2 factor in the second part, so we have multiplied with 2. Then this will be plus half plus x power n plus 2 into dx. So let's bring down. As you can see, we are summing over n part, right? Take the n part common here. Then this is half into integral 0 to 1. If you take x power n as common here. X power n, write it down here. Summation q belongs to n naught cos of q pi by 2 into, if you take x power n as common here, if you take x power n, then the remaining part will be, it will be 1 into x power n minus 2 into x, right? 2 in 2x into x power n, it will be x power n plus 1, right? Then this will be x power n, this will be x square. Fine. This is how we have written. Then let's simplify more. This will be half into, we have calculated this value, right? Let's write it down this first. 1 minus 2x plus x square. Yeah, this 2. As you can see, the q value is n here, right? This q value is n here. Then this is from equation 2. Here q is n. Just remember that this will be 1 plus x square, as we have substituted here. While substituting this, you can write it as q plus 1, right? I have just interchanged the numbers. You can do that. 1 plus x square into dx. So you can remember this formula, right? Integral f dash of x by f of x, which is ln of f of x. As you can see, this part is, oh no, I don't think you can use this formula. This is half into, let's do one thing. Let's write it here. 1 plus x square by 1 plus x square minus integral 0 to 1 2x by 1 plus x square dx. This is 1 by 2 into, this case dx, right? This will be x, then substitute 1 minus 0. Then you can use this formula here. If you differentiate 1 plus x square, it will be 2 of x, right? Which will be 2x, then it will be ln of 1 plus x square. Integral limits are 0 to 1. This is half into 1 minus 0 is 1 minus, this will be ln of 1 plus x square. X square is 1 square, then it will be ln 2. Ln 1 plus 0 will be ln 1, which is 0. So this is half minus half ln 2. You can more simplify it. I mean, you can write this as half ln e, which is 1. This will be minus half ln 2. This is half of ln of e by 2. You can write it as ln of root e by 2. Fine. So our final solution here is summation q belongs to n naught cos of q pi by 2 by q plus 1 into q plus 2 into q plus 3 equal to ln of root e by 2. This is the final solution.